Hey everybody, and welcome back. This is Rational Functions, and this is the introduction to rational functions. I'm assuming you've never seen a rational function, at least with a variable before. I'm assuming you have dealt with fractions before, but this is kind of more complex. So what they are, why we love them, what we can do with them, and kind of some of their key features. So this is just going to be an intro video for you guys today. So what are rational functions? Like, I guess as, a proper definition, what we say a rational function is not that because that's basically invisible. A rational function is a function such that we have a p of x over q of x where p of x and q of x are polynomials. So that's the very technical definition. Basically, just think of it, I have a polynomial in my numerator and I have a polynomial in my denominator. So a rational function could look something like 3x over x squared plus 2. A rational function could look something like maybe I only have a constant term in my numerator, maybe I only have a constant term in my denominator. So the regular fractions that we kind of have come to know and love, these are also what we consider rational expressions or rational functions as well, right? Constant term over constant term. This is a linear term over a quadratic. They could also look something like I don't know, x to the fifth plus 5 over, and I don't know, I want a constant term on the bottom, right? So think any polynomial you've ever seen, right? Constant terms included, linear terms included. Any polynomial you've ever seen, that can go in the numerator, and any other polynomial you've ever seen, that can go in the denominator, right? So just think of a rational function, hey, this is a polynomial over a polynomial, and all of the fractions that I already know about, those are also included as well. So those are what rational functions are. We're just two polynomials hanging out on top of each other. So with rationals, we do have an issue that we did not previously have in polynomials, and that's the issue of these guys being undefined. Well, what do we know about kind of when we were in just constant rational function land, right? When we were dealing with things like 2/3, what was always the thing that we were told? We can't ever divide by 0. Yeah, so we can't divide by 0. So if we have something up top, and I'm just going to write p of x, right? Some polynomial or constant term or linear term or whatever on top, what can we not have on bottom? Well, we can't have a 0 on bottom. This is a big, giant no. No, 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 no. We created a singularity. We kind of create a black hole in this situation. So no, we cannot divide by 0. So 0 in the denominator, bad, right? Think about your thumb. 0 in the numerator and a polynomial on bottom, this is fine. This is fine. Yay, this is just equals 0. This guy equals 0. Or a 0 in the numerator, polynomial or whatever term on bottom, 0. Polynomial in the numerator, 0 in the denominator, this creates an undefined situation. So rationals are undefined when denominator equals 0. Bloop, bloop, bloop. So we just really don't want to have a 0 in the denominator. So anytime that there's even a hint that there's 0 could be in the denominator, we don't want it. So we want to try to avoid that situation as all as possible, or we want to identify it. Be like, hey, there's going to be a 0 in the denominator at this point. And we'll go over later what we do about that. But just know rational functions are a little different than polynomial functions because they do have an undefined point, and it's when 0 is in the denominator. Okay, so we do not want 0 in the denominator. So what can we do with rationals? Right? Well, we can do everything with rationals that we could do with fractions, right? So anytime you hear the word fractions, fractions are rational. So what could we do with our fractions? Well, we could add them together right? We could subtract them. We could multiply them, and we could divide them. 2/3 divided by 5/6, right? All of these were valid operations, and they still are. So any rational function you see, or rational expression, we can add rationals together. We can subtract them from each other. We can multiply them with each other, and we can divide them with each other, right? We're used to doing all, and everything that you know how to do with regular constants or with fractions, the operations are going to be exactly the same. We're just going to throw some letters in there at you guys with variables. But everything you know, like how do I add fractions together? Well, I need a common denominator. Hey, that's going to be the same exact thing. You know, how do I multiply two fractions together? Well, I multiply straight across the top, straight across the bottom. Hey, that's going to be exactly the same thing. Hey, how do I divide fractions? Well, dividing by a fraction is the same thing as multiplying by the reciprocal. That's going to be exactly the same. So everything is going to be exactly the same. It's just now we're going to be looking at, you know, stuff like adding things like this together. 2x minus 5. Right? And so it's like, well, I knew how to add that together, but how do I add this together? Well, it's the exact same thing. We still have to create a common denominator. It's just going to look a little bit different because now we're throwing in some variables. But think about it in the exact same way. So we can do all this stuff with rationals. So the same stuff that we already kind of knew about. So what are rationals used for, right? When I throw letters and variables in there, well, why are we doing that? Well, these help us solve equations that use ratios and proportions. So anything that's kind of proportional to something else or something that happens like in proportion of this other event, those are useful. Physics calculations, rationals show up in physics all the time. And what are physics? Physics are the laws that govern kind of space, time, our universe. So that's literally infinitely important. And for kind of a more tactile thing, we calculate how much medicine to give a medical patient relative to their weight. So that's also something kind of solving with a proportion, right? So for anybody who's in the medical field, they use rationals all the time. So thank you. I hope that was a good intro for you guys. In the following videos, we'll learn how to add, subtract, multiply, divide, simplify. We'll solve equations with these guys. So we'll do a lot of different things with rationals, all right? As always, whenever you guys have questions, please don't hesitate to ask.